Hello, in this video we will introduce how to use R to calculate the results in logistic regression. So first we will talk about a little bit about generalized linear models. So we know for example, linear regression, the independent variables can be categorical or continuous variables, but the dependent variables should be assumed as at least approximately normally distributed. But in many occasions, such outcome variables are not normally distributed. For example, the outcome variables can be categorical. They can be binary results, binary variables, or yes or no, or passed or failed, or lived or died, or polytomous variables. So this means, for example, they can be multiple categorized. For example, poor, good, excellent. And in other occasions, outcome variables can be accounting variables. For example, the number of traffic accidents in a week, the number of drinks per day, and so on. So these situations make the probability to set up the more generalized linear models. So generalized linear models means that we do not assume Y follow normal distribution. Instead, we assume Y follows a distribution such as a member of the exponential family. So many distributions come from exponential family. So this is the basic form for the generalized linear models. So here is G mu Y, which means this is a link function. And on the right side is the same as the usual linear regression models. It's just the independent variables times their parameters and their summation. So in R, we use GLM function. So here we use the formula. Formula is the same as this one, and the family is called probability family. So this depends on model types, and the link also depends on the model types. So we will show examples later. So logistic regression is a model that applies to the situations in which the response variables is binary, so 0 or 1. So here 1 is like the true or false, the true in a binomial trial or Bernoulli trial, binomial distribution. So in each trial, we get the results 0 or 1. So for logistic regression, we can use this form. Here is the link function. So log pi divided by 1 pi. So what is pi? Pi is the probability in the binomial trial. So this is in the long run, what's the probability of getting success in a trial? If here we assume 1 is for the success, so probability for 1 is pi. And 1 minus pi is the probability of 0, right? Because this is binary, so probability of 0 and 1 summation is 1. So here is for the true, here is for the false. So this division called odds. And log odds is called logit. So logistic regression can be expressed as the logit on the left side, and the right side is summation of the independent variables with their parameters projection. So the function in R is GLM Y and x1, x2, x3, and so on. Family is binomial, and the link is a logit, and with the data. So next we will show an example using logistic regression in R. the example, use the data called affairs, and this is included in the package AER. So you have to install this package first. And the data includes 9 variables for 600 observations, and these variables include the person's gender, age, years, married and children, and religious and education, occupation, and very important variable is called rating of their marriage. So 1 is very unhappy to 5 is very happy. And their extramarital sexual intercourse number during the past year. So this is the dependent variables we are interested in. So we show this data first in RStudio. So we have installed the package AER. So we use data affairs. So load this data, then summary affairs. You can see the summary statistics for each variables. For example, affairs. Affairs, this means extramarital affairs, or say the cheating numbers during the last year. So minimum 0 and maximum 12. And the gender, female 350 and 286 for male. And age, minimum first quantile, maximum, and so on. And years married. Education, occupation. And occupation, we also have codes, minimum 1 to the 7 to maximum. And the rating, a minimum 1 and maximum 5. Then for these dependent variables, affairs, we use table to show the frequency. You can see for 600 people, about 75% are 3 or 4 have no extramarital intercourse, and the other 150 have, and ranging from 1 to 12. Then, because we here showed example of logistic regression, so the results will be 0 or 1. So we transform this, or create a new variable called yn affair from the affairs variables, original variables. So if larger than 0, we set the value 1 for this new variable. And if not, so we also set 0 for this variable. So the results will be categorical and 0 and 1. And we transform these variables to as factors too, with the label 0, 1 and the labels no, yes. So we show again the new variable yn affairs in this data. So it's quite clear. 451 people have no extramarital intercourse, and 150 have yes. So next we can create a model, and the model will be assigned to, results will be assigned to here fit4, because we use all the independent variables. So here we use the name fit4. And the glm yn affair, then on the right side includes all independent variables, and with the data as affairs of family binomial. Because binomial default link function is logit, so here we do not need to set logit here. So to run, and we use summary function to show this glm regression. So this is the formula, and coefficients for each variables. You can see several variables are not significant, like occupation, education, and children's and gender. Here AIC will remember this number 627. So next we use a reduced model. We only set in variables which are significant in the full model. And similarly, we show the summary results of this reduced model. So all the variables are significant. And the AIC are lower, so which means this model are better. And additionally, we can use an ANOVA function to test if the reduced model are significantly different from the full model in appearance. So we use ANOVA fit reduced first, then fit full, and test with a chi-square. And the results show that the p-value is larger than 0.05. It's not significant. So this saying that the reduced model does the same job as the full model, right? Because they are not significantly different, so we can use the reduced model. And we show the coefficient, use COEF function for this model. This is the mean value for this coefficient. And because the model in logit, you see on the left side is the logit. So if we want to show the odds, not the logit, so we can use a function, or we can use function exp exponential of these coefficients. So which means one unit change of the independent variables, for example, years married or ratings, will get the odds 110% large. This is 63% less, right? Less than the original one. Odds. Here is the odds. But in the original model is for the logit, log odds. Because the log odds may be different to explain. So here we use exponential of the coefficient. So this means that one unit change of independent variables will result in 110% of the change in the odds. Odds is the division between true probability and false probability in a binomial trial. So next we can create some test data to see what's the probability of extramarital sexual intercourse. First, create a data set with the same variables except that rating from 1 to 5. Here rating is for the marriage rating. Then we can use a predict function from this estimated model and with the data and type called the response, because we use the here response means we use the y variable here directly. The probability and test data. So here we have a data frame including one new column called the problem. So this means the probability is the true probability for this sexual intercourse. So which means, for example, age, years married, religious are the same, but if the marriage rating from 1 to 5, the probability will be lower from 0.53 to 0.15. And we can create another test data in which the age will be different, but other variables are the same. And we predict this model, this probability based on estimated model with the new data. And you can see in this new data frame, the probability, if we change the value from 17 to the 57, and the probability of extramarital sexual intercourse will be lowered from 33% to 10%. So in this video, we only show the surface of the logistic regression using R, using GLM function. And there are more functions, more applications can be applied in this function, GLM large family function for the logistic for the generalized linear model. Thanks for watching.